Okay, first thing that we need to talk about in geometry as a whole is just the basic vocabulary. So geometry is just the study of kind of space, of shapes and space. So here are all the different vocabulary words that we need to talk about. The most basic vocabulary to start with is a point. Here's what I need you to know about a point. A point is a location in space. And it's represented by just a dot. So a dot in space is a point. It has no dimension. So in other words, no measurement. We can say the location of a point, but a point doesn't have a size. Okay, so on the right, we see the picture and we see a label. So the picture is that dot. The label is a capital letter. So just to be clear, if I have a point here and I'm calling it point D, and I wanted to refer to that point, I would say point D. There is no symbol. So what a lot of people will do to refer to that is they'll make a little dot and put D next to it. That's wrong. That's not the label. The label is the word point, or to refer to it, you're writing out the word point, and then whatever letter you're giving it. Has to be a capital letter, though. Okay. If we take 2 points and connect them, we get a line. So a line continues forever in 2 directions. It has 1 dimension. And any 2 points form a line. So if I give you 2 points, there is some line that connects them. Okay, so you see a line to the right. We see this point A, this point B, and those points were connected with a line. There are many ways that you can refer to that line. You can put the 2 points and write a line over the top. You can do it the other direction as well, so it doesn't matter the order that you write those in. The other one is you can use a lowercase letter and the word line. So those are really the most common. I would say what I wrote in blue is the most common. Choosing any 2 points on that line. You can write out the word line. So there's a whole bunch of different ways. I would like us to draw an example to the left just to make sure that we are clear. So if I have that line right there, and I wanted to name that line, what is most common is going to be to identify 2 points on it. So I might put a point here and call it L, and put a point here and call it X. And then that line is LX, and I can put a line over the top. What is very important are these arrows, because these arrows show us that the line keeps going. So these arrows show us the line keeps going. If you don't put arrows here, that means something else, and we will get to that. Okay. Now the question is often asked, how many points are on this line? And initially we're tempted to say 2, right? L and X. But there's a ton more points than that we don't see. So there's a point here and a point here and a point here. So how many are on the line? Infinitely many. So I'm going to say there's infinitely many points on this line. We just can only see 2 of them. Okay, so points make up a line. Points and lines make up what is called a plane. So a plane is like a piece of paper that continues in 2 directions or dimensions. So here's what I mean by that. This is my line. It continues this way and it continues this way. If I consider this my plane, it's going to continue this way, this way, this way, this way, everything that's horizontal. Okay, so what was key above is that any 2 points formed a line. So if 2 points form a line, to form a plane, we need 3 points. So 3 points form a plane. But here is what is really, really important. Those 3 points cannot be on the same line. So 3 points form a plane as long as they're not on the same line. So here's what I mean by that. Off to the left, if I have this line that has points A, B, and C on it, those points are on the same line. They do not form a singular plane. There are multiple planes that go through those 3 points. So if we consider this line that has points A, B, and C, and we think about how many pieces of paper could contain this line, many of them. I could put the piece of paper like this, I could tilt it, there's a lot of them. That's why if our 3 points are on the same line, they don't form one single plane. So if we wanted to form a plane here, we would have to add in another point. So maybe I add a point D here that's not on that line. We then have some plane that contains these points, and we would name that plane by those 3 points. So I could call this plane ABD, or BCD, or DCA. There's a whole bunch of different combinations of what I could write. So how I name the plane is probably different than how you would. But again, there's no symbol. So like I said with the point, a lot of people want to put a dot in front of it to show that it's a point, and we don't do that. Same thing with a plane. You have to write the word out. So far, line is the only one that has a symbol. Line has a symbol, point does not, plane does not. You just have to write the word out. Off to the right. So this plane is labeled by the 3 points ABC. You can also label a plane just by one capital letter. I don't do this very often, but you can. So just one plain capital letter. Okay, we got 2 more words and then we're going to do some examples. These probably make sense to you, collinear and coplanar. What does co mean? Together. Okay, so collinear, together on a line. So that is points on the same line. Thank you, appreciate it. for example, if we have this line right here, P, H, and S are collinear. Collinear, they're on the same line. Coplanar, on the other hand, again, this should make sense. Co together, planar, plane. So points that are on the same plane. So if we have this plane right here and we put P, H, and S, those are coplanar. Those points are on the same plane. Questions before we do an example? Okay, so let's take a look at this first example then. We have this figure to the right that you see over here with a whole bunch of labels. Part A, give 2 other names for line M. Okay, so if we look for a little M, we see it here. That line M contains 3 different points. So that line contains points S, P, and T. Now, if we remember, though, a line needs 2 points only. So I'm not going to use all 3. I could call this line SP. We need that little line over the top, and you have to have the arrows. I could call it PT. I could call it ST. I could reverse the order and call it TS. And there's a lot more. Okay, so B, give 2 other names for plane R. So we see that capital R, that's a plane. So this plane contains points V, S, P, and T. So we have 4 different letters to choose from. That being said, a plane only needs 3 points. So here's my question to us. Can I choose any 3 points that I want from these? No. Who said no? Zulkarnain? Okay, why did you say no?
Because some of them are on the same line.
Okay, so which 3 can I not choose? S, P, and T. Great. So we cannot say, and I want you to write this down, plane SPT. That is the only one that is not allowed because those points are on the same line. So I could say plane VSP. That's fine. And then if I'm really just lazy and I want another one, or not lazy, I want to be efficient, I can just take those 3 letters and reverse them. PSV. That's another name. I'm not going to write that down because I ran out of room. Okay, 3 points that are collinear, 3 points that are on the same line would be S, P, and T. And you are not writing dots of any kind, you are just writing the word point out in front. And then 4 points that are coplanar, we already answered this. Points that are on the same plane would be points V, S, P, and T. Questions before you all try one? I would like you to go to the next page. You are doing this example at the top with the person next to you. So you can move desks if you want to, or you can just turn your body, whatever is most comfortable to you. But please do A, B, C, D. Okay, here are some possible answers. These are not all of the answers. 2 other names for a line. Pick 2 points on that line. You have to have a line above to show that it's a line. Just writing CE is not enough, or CD is not enough. For a plane, you need to write the word plane, and you should have 3 points on that plane. There's many options. You cannot, though, say plane GEF. Why not? Why does that one not work?
They're on the same line.
Because they're on the same line. 3 points that are collinear, there's two options, G, E, F, C, E, D. 4 points that are coplanar would be G, E, F, and B. How did we do? Okay? Okay. I have one more question for you before we add on to this. So can you write this, please? Are points C, E, B coplanar?
No.
Are points C, E, and B coplanar?
No.
Okay, let's come back. Show of hands for people who say no, not coplanar. Show of hands for people that say yes. Ooh, Diana and Abigail. I'm going to ask you guys to talk since it seems like Archer. I didn't see. Were you in Berkeley part of the yes also? You're part of the no. Okay. Abigail and Diana, you guys are looks like our only two that say yes. Can you give me an idea why you say yes?
Because C is on the same line
As E? Okay.
so E is on a plane, so line has to be on one plane.
Okay. I don't know if I quite follow. Abigail, do you have anything you want to add?
I don't think so.
Okay, Diana, try one more time to explain to me.
Line has to be on the same plane. So point is on the line of the plane. So and C also is on the same line.
Okay. Okay. Everybody else says no? Okay, let me ask the question in a different way. Does there exist a plane that contains C, E, and B at the same time?
No.
How many points make up a plane? How many points form a plane?
3.
3. 3 points form a plane. So let me ask again, is there some plane that contains C, E, and B?
No.
Yeah, there is. We just can't see it. It's just not drawn for us. Any 3 points at all form a plane. So are C, E, and B coplanar? Yeah. Yes, they are. Any 3 points form a plane. So any 3 points form a plane. So Diana, you were correct. Okay, I want to get through this next set of vocabulary and one example. Well, I want to get through this page, and then we will take a break. Questions on what we've done so far? Okay, next thing to talk about is a line segment. A segment is part of a line with 2 endpoints. So if we have this line right here, A and B, and we want to refer to that line, I said it's really important to have the arrows over the top, because what that shows us is that this line continues indefinitely in both directions. What a segment does is it says, I want to stop at A, stop at B, not look at this stuff, and only look at the part in between. You name it exactly the same way. You still just take the 2 points, but you put a segment over the top. There's no arrows. Here is the biggest difference. When naming, you have to use the endpoints. For a line, you could use any 2 points at all that are on that line. But for a segment, we have to know where do we start, where do we stop. Okay. Array is related. Array is, again, part of a line. It only has, though, one endpoint. So let's start with our same line. From above, we have this line AB. What array does is array chooses 1 point only, like point A, and then continues in the other direction. The name is very specific. We always start with the end point A and the direction it's heading B. And then over the top, start at A, head toward B. So I'm going to write this. Start at A, head toward B. That is not the same thing if I switch the letters. So if I switch the letters and write B, A, and then I write array over the top, that is a different ray. That is the ray that starts at B instead and heads in the direction of A. So for the ray, the letters really matter. The order specifically, where you start, where you head. Last one is opposite rays. Opposite rays are two rays that share the same endpoint and they form a straight line. So in the figure, we have two rays that we're referring to. There is one ray that starts at C and head toward B. So that's this way, start at C, heads towards B. And then there's another one that starts at C and heads towards A. So starts at C, heads towards A. These two rays are opposites. They both form C. They head in opposing directions to form a straight line. I'm going to do an example, you'll do an example, and then we'll take a break. Okay. So, here we go. Give another name for segment GH. So that is saying start at G, go towards H, stop at H. For a segment, you have to use the endpoints. So we only have two options here. We can say segment GH with a segment over the top, or we can say HG. That's it. If I said something like JG instead, that's different. JG would just be this part right here. Which is not what I'm referring to. Okay, So then the next one, name a ray that has J as an endpoint. So it's J and then heading towards some other point. How many different directions can we go from J? 4. We can start at J and head towards E. That's 1. We can start at J and head towards F. We can start at J and head towards G. We can start at J and head towards H. And then opposite rays, we can see in the picture. Opposite rays form a straight line. So there's a pair of opposite rays here. That would be JG and JH. And then there's another pair of opposite rays there, which I'm not going to list. In the example that you are doing, I want to point out you are naming all and both. So you're going to do this example, we'll go over it, and then we will take a break. So like before, turn to the person next to you and do these 3, please. Here's what I got. How'd we do? Okay, question for you all. This ray, for example, PS, if I switch the letters, is that the same ray? No. That would be the ray going in the other direction. What if I was referring to a line and I switch the letters? Are those the same?
Yes.
Okay, so those are the same. Yes, those are not the same. Okay, let's flip to the next page. Next thing you're talking about is intersection. Intersection is just what 2 figures have in common. So if we look at this figure on the left, what do those 2 lines have in common? A. So we would say the intersection is point A. Do 2 lines always intersect at a point?
No, they could be parallel.
They could be parallel, so they don't intersect at all. The intersection of 2 planes, those 2 planes we can see intersect at a line. Do 2 planes always intersect at a line? No, they can be parallel. Okay, and then if we look to the figure on the right, we have a plane and we have a line. Where do they intersect?
Point A.
At point A. Okay, we are going to do this example together. Specifically, we're going to do 3 and 4. I don't think we need to do 1 and 2. Name the intersection of plane ADH. Where is plane ADH on that box?
The outer part.
Which face of the box is it? The front. Okay, so we're taking a look at the front. And then plane DHG. Where is that?
The side.
The side. The right side. Okay, so they intersect at this DH. Now, keep in mind, these planes go on forever. There's no way for us to display that. So DH is really a line. It's written like a segment, but it's a line. Okay. Plane ABE. So now I'm on question 4. Plane ABE. Where's that? Left side. Thank you, Marin. Left side. So that's this right here. And then segment AD. Segment AD is here. Where do they intersect? At a point. Yeah, at point A. Just that point right there. We okay with that? Okay, let's just keep rolling then. Some more vocabulary. Postulate. Postulate is a statement that is accepted to be true. So it's not proven, it's accepted to be true. Okay, this is really big. Congruent means the same. So when we say congruent segments, that means segments with the same length. Okay, here's what I need us to see from this figure. These tick marks show congruence. So those tick marks are conveying to us that the length of AB is the same as the length of CD. We say that lengths are equal. To put geometry notation in is what we have to the right. And so what I want you to see on the right is we have segments. So we have segment AB and segment CD. And you don't just stick an equal sign in the middle of them. The congruent symbol has that equal sign, and then it has a tilde over the top. So when you see that symbol means congruent. And it just means that the segments have the same length. Now, if we were asked, can lines be congruent? You would say no, a line doesn't have a measure, it doesn't have a length, it goes on forever. Okay. Last piece of vocabulary is midpoint. A midpoint is, like it sounds, a point that cuts a segment into two congruent parts. So in the figure, we have this midpoint M. The reason we know it's a midpoint is on either side of the figure, we see these tick marks. So these tick marks tell us that this segment is the same length as this segment. That's what makes M a midpoint. If I put another point in it, like I put a point here, that is not a midpoint, because the distance to the left is not the same as the distance to the right. So the midpoint specifically has to be in the middle. Questions before we do an example together? Okay, so let's look at the example on the next page. We are going to start by plotting 4 points. Okay, so point J, -3, 4. Starting at the middle, how do I do the -3? Which way do I go? To the left. Okay, so I'm going to go left 3 and up 4. And that is my point J. For K, I'm going to go 2 to the right and up 4, and that is K. And as we can see later in the question, we're looking at segment JK, so I'm just going to connect to those right now. There's no arrow because it's a segment. Different color now, I'm going to do L. L, so I go to the right 1 and I go up 3, and there's my L. And M, I go right 1 and down 2. And I'm going to connect that. And we are asked if these two segments are congruent. So in our mind, we're asking ourselves, do they have the same length? Well, in the figure, we can count. How long is JK? 5. We're just counting the boxes. LM. So we see 1, 2, 3, 4, 5. Also 5. So then are they congruent? Yes. JK is congruent to LM. And again, it's not a plain old equal sign. It's got a tilde over the top. Questions before the last thing? Okay. We are just going to skip this postulate because I think it makes intuitive sense. So we're just going to look at the examples. If we look at this first example, we're finding DF. So we're finding this length. What do you think we have to do? Just add, right? I have 23 here and 35 here. So the total DF is going to happen when I add those together, which gives me 58. B is a similar idea. B, I'm looking for GH. Now, adding in this case does not make sense. If I take 21 and 36, I'm going to get a bigger number. Shouldn't GH be smaller than 36?
Yes.
Okay, so instead of adding, I'm taking the whole, removing the part I don't want. So what operation am I going to do? Subtract. Okay, so my GH then is going to be 36 subtract 21, which I think is 15. We are going to do these last two together, and that'll be our notes for the day. XZ. So in the figure, if I'm finding XZ, how would I go about that? Add. And so XZ, I think when you add those, you get 41. And then in B, if I'm subtracting, oh, I already told you. What should you do? Subtract, right? Adding doesn't make sense. So if we subtract that 25 and that 19, we get our CD to be 6. That's our notes. Thank you for sticking with me. I know those were long.